Start recording. Okay, great. Okay, so the next part of this is going to be creating the attractor points and the spikes that sort of attract to the attractor point. So an attractor point is essentially just a point somewhere on the geometry that all of the other that some element of the geometry like points towards or is influenced by. So if I go to just like Google Images and look up attractor points, yeah, I'll just look up attractor points, grasshopper. So essentially it's like something like this, right? So you can see that this is just a bunch of like hexagons, like tiled hexagons that decrease in size the closer they get to that attractor point, right? So it's pretty simple. It's just some kind of geometry deforms as it gets closer or further away to a point, and then you can move that point around and change the geometry, right? So something like, like this. A bunch of facades in sort of more modern buildings have something similar to this. You see sort of like art installations on walls that kind of have a flowy design like this that's influenced by attractor points. So that's what we're going to be doing. We're going to be making the spikes on our sort of like pinecone shape get longer as they are closer to the attractor point and shorter as they're further away from the attractor point. Yeah? All right. Cool. Okay. So back to our script. So the first thing we have to do is actually create the spike geometry, and then we're going to vary its length based on the attractor point. But we'll get to the attractor point later. First, we're just going to create the spikes. So first thing we want to do is go back up to our join curves. So this represents like the boundaries for each of these panels that we made earlier. Probably best to label this like boundary curves or like panel boundaries or something. Panel boundary. This is just the curves that define the edges of our panel. Next, we're going to go and explode them into segments, just like this. So this curve came out of our loft, our edges, and our join curves, and it should be a flattened list. And then we're just going to tack it and explode onto the end on the ends there, and then just bring that down here so it's sort of out of the way. Okay, cool. So next thing we are going to do is get the endpoints for these exploded segments. Now we're going to be working with sort of untrimmed lists and stuff, so the sort of lists are going to get quite long, so you'll have to follow along kind of carefully to make sure we don't cross over our lists. So this is, I'll just put like a little scribble here, two joined panel boundary curves. Nope, panel boundary curves. Yeah, so this connects to this set of curves. Yeah? The one that's connected to the polygon center. Cool. All right, next thing we're going to do is evaluate curve. And that is going to go into our segments as well. This is how we're going to create the start points for our spikes. So let me just go back up here. Where is that going to be connected to? Spikes distance. Okay. So this is going to be from 0.0 to 1. And this is going to be the spike distance. Now, when you're creating your geometry at home, you don't necessarily have to create spikes. You can do any other sort of extrusion, any kind of different geometry. You could change the openings here based on the closeness to the attractor point. You could change how far out the extrusion is for the mesh. It's basically a parameter that you change based on the proximity to an attractor point. So it doesn't have to be spikes. Spikes are just kind of an easy way to visualize it because they're sort of just like a direct visualization of a length of something. But you don't have to do spikes. You do bubbles, something else. Doesn't really matter. I might show you, if we have time at the end, some sort of alternatives that you could do. Anyway, okay, so we want this to essentially be reparameterized. We need it to be grafted so it matches the number of curves we have. And we're going to do a 1 minus x thing here so that we get it on both sides. So if I put in an expression, I'm going to do an expression that is 1 minus x. I'm going to get rid of the y variable and then move that in there. And essentially now we have a bunch of points on either side. So when you highlight your evaluate curve, you should have these points. You should have your center point, your... Oh, sorry, if I increase the spike distance, that's better. There we go. So we should have sort of 4 points surrounding the center. Let me just make sure I've got this right, but I think that should be good. Oh, yeah, we need to reparameterize it and graft it. Reparameterize and graft. My bad. And now that should give us an even direction from the center. So essentially, 0.5 represents how far it is along the curve. So 0.5 is the midpoint for the curve, so it stays there. If I push it back like this, then we get it. We'll have our spikes being a little bit closer. You can have it however far out you want. That should be fine. Yeah, and it's grafted so that the list structure matches our endpoints here. Okay, so the next thing we're going to do is construct some vectors. This looks a little bit complicated, but that's only because there's a bunch of different layers on top here. Basically, just focus on the components for now. We're going to get our vector from the center point. So first thing we're going to do is get our 2-point vector, right? The 2-point vector is basically going to change based on our center point here. So our axis center point that we created before goes into the A of the 2-point vector. Actually, let me just check if it does go into the A. Yeah, it is. And then B goes into the start point. B goes into the end point. Start point, start point. Or is that start point or is that end? No, it's end point. All right. Okay. So we're going to create 2 of these. So the A goes into the axis center point that we made, and remember that comes out of the evaluate curve. We need a start point and we need an end point, like that. Hopefully that helps a little bit. So the axis center point was literally just, where is it? It's this thing here. And if you were doing this with another kind of surface, so not a revolved surface, your axis center point doesn't need to be a center point. It can literally just be a point that moves around within the bounds of the surface. So instead of doing an evaluate curve here, you would do an evaluate surface, and that just puts a point somewhere on the surface. Yeah. Right. That might be because you don't have that axis that we had before. So just do an evaluate surface on your base surface that we had, and it should be fine. Or because yours is kind of like a vase shape anyway. Yeah, it could. You could just put move like a point in Rhino and put it in the center of your vase, and that can be your center point. Yeah. Essentially, all it needs to be is a point for the spikes to sort of reference somewhere. Is it like the center? Yeah, so if you can imagine the spikes sort of extending from this center point out through this junction, it's essentially just that. So you can place it manually in Rhino, or you can use like a construct point component in Grasshopper, however you want to do it, it's fine. All right, so we've got our vector 2 point. The A, so the first point for each of these vectors is that axis center point, or if you're doing a different one, just whatever center point you choose. And the B is going to be our start point. And then for the second one, it's our end point. Yep. Great. So back into this tangled mess. So we have our amplitude, and that basically just describes how far our wow, okay. Jeez. That's fine. All good, no worries. Okay. So, amplitude. Amplitude just describes the length of a vector. So, our vector goes in there, just like that. So we have two amplitudes connected to two 2-point vectors. You don't need to put anything into the A of the amplitude just yet. We'll do that later. But we are going to be moving our endpoints by... Actually, no, we do need to put something in the A, but we'll get to it in a second. So, grab two moves. And we're going to be moving our start point and our end point. All right. So if I plug this into here, essentially we're not going to get what we want, but we're going to tidy it up a little bit. And then while we work on the next part, we're just going to leave this as it is here. Yeah? So if you want to just double check you've got the right script, just we can pause for a bit and leave it there. Yep. So so the explode doesn't go on the points. It actually goes from those joint All right, so the next part is actually constructing our attractor point. And the attractor point is going to determine what vector we move this by. The length and the amplitude of the vector is going to plug into the amplitude of this vector component that we just made. Yeah, there's probably a better way to organize this than the way I've done it, but that'll do for now. Essentially, what we're going to do is create a bunch of vectors with different lengths based on how close they are to a point, and our vectors are going to go into the amplitude, and then we're going to move our spikes by that amplitude. So, first thing we're going to do is come down here, just somewhere in your script that isn't close to the other one, offset surface. So this basically offsets your surface, like your base surface, which is this one that we had way at the start, by a set amount. So the distance that we're going to offset it by, I think, is not going to be too much. It's actually just going to be the maximum length of our spikes. So however long you want your spikes to be. I'm going to say like 15. Yeah, just hang on one sec. All right. If you're doing your offset surface and the surface that it creates is like inside your other one, all you need to do is just change the expression. Where is it? Change the expression to negative x. Negative x. So essentially, this sets the limit to where your spikes can like stick out to. So my spikes can come from like here all the way out to here, and that's as far as they can go. And then if I make this smaller, obviously the spike length is going to be smaller as well. Yeah? Negative x. If you're creating it and the surface it creates ends up inside, then just change it to negative x. If yours is on the outside, you don't need to change anything. Yeah? Just dash lowercase x. All right, and then our offset surface, we're going to evaluate a point on that surface. So if I go to evaluate surface, and then reparameterize the surface, that means that the x and y is now going to be from 0 to 1 instead of their actual lengths. And then I'm going to put in an MD slider. So a few of you might have seen the MD slider before. But essentially what this does is it moves a point, well, it sort of defines a point in the x and y direction simultaneously. So instead of having to do a slider for x and a slider for y, this is sort of like a 2D slider so that your point can be anywhere on the surface, yeah? So if you see, as I move around this MD slider, the point moves around the surface. Yeah? And this also gives us a bunch of factors, about a bunch of parameters that relate to the point. So we have the point itself and its coordinates. We have the normal vector. So that's just the vector that points directly out from the surface. We have its u coordinate, its v coordinate, it's v vector and u vector, and then we have just a plane at this surface. That's all good. So has everyone got this? An offset surface, an evaluate surface, and then an MD slider to define where the point is? Yeah.
So my point is like at the very, very tip of my shape, and it doesn't move much.
Yeah, you might need to reparameterize it.
Which
So that's Go to the S and then click reparameterize. Yep. Okay. The negative X didn't work. Hmm. Did you change the distance on the slider?
Yeah.
Okay. Let's have a look. Oh, I think it's just the distance that you modify. So you just might need to up the distance. Just something higher. So I have mine at like 15, but yours might be off the scale. That's weird. That's really weird. Okay. I guess just keep upping the distance until it works. Sorry, I don't know how that's. Yeah, yeah, yeah.
Bloody hell. Well, it should stop raining at 3 p.m. I don't know, it's whatever you want. I don't think it matters.
Yeah, so two guys. Right.
That I was meant to be one guy for on photo of him. And he sat outside on my doorstep and he saw me waiting for him. I was like, I'm not waiting for you, I'm just getting some sun. I was waiting for him to come. He gave it to me in my hand. That's how embarrassing that was. Type of stuff that like my mom goes and then it just I couldn't wear it. Yeah. Because there were a lot of people like 3 or 4 months and I'm just like, now I have more stuff now what? More stuff. Wait, I don't like shit spend any money. I go off really like big percent, have to spend 70%. 70%. 70. I'm getting that hurt. Remember that? Yeah, yeah. I'm gonna buy my nails. I look at it and think the white box. Like White House. My friend went and she was like, it was disgusting. Why did you tell me? I got it. Like they would jump with Rachel. That's part of the stuff. But no, I went there. It was nothing. And she got some good stuff. That French one didn't tell you. I know. Didn't you get the mug? Like, wait, what? Wait, what? You don't? Up to cents. Uh-oh. I have this obsession with like trash cans. Like, oh my god, my last few lessons have reversed with the puffer jacket. It's black and like yeah, I bought it so bad. I gotta buy it, and then mind you, it was like $20 to get jacket like $45 for like a puffer jacket. That's worth it. It's really good. I go and buy it, sold out. I'm like, oh my god, it's sold out. From this game, I took the last one. I was like, you had to do it. I was like, you had to do it. And it's been sold out. And now I'm out of it. Like, it's just the one color is like $90. Yeah, and then Cotton has a reversible one, but it's white and brown. Yeah. And I don't want to keep like brown. I wanted like the same color all through. Yeah. I would buy the brown and white one. Or I would buy the brown one, but I want black. Like it's really good. It's like I think it's 75 as well. That crazy. No, 70. 74. Yeah, it's 71. That's cute. It's not 5 to 71. I'm just thinking.
Alright, so yeah, this method won't work for some shapes, but it'll work for our revolved surface shape. Okay, so we have our points. Basically, we are going to define that point with like a sphere, just to make it easy to see. So grab your sphere component. The base plane for the sphere is just going to be there. So now this should be an easy way to sort of get an idea of where your point is. Yeah? So our sphere is going to move around as we change the position of it. That doesn't really need to. Did you use the right sphere component? There's a red one and a yellow one. Yeah? Your radius just might be small, I'm not sure. You might have like the wrong scale. So if I type in sphere, it's going to give us this one and then this one. Alright, well it's okay, you just want the yellow one, whichever one's the yellow one. You might need to change your radius, like my radius is default 1, but yours should be whatever will make it appear. So now essentially we're just going to create a bunch of lines going from our attractor point to our endpoints that we created before. So let me just move all of this that we just did just down here so that it's sort of all good. I'll label it as well. You can put a slider into the R if that helps. Or you can just right click it and do set number. Doesn't really matter either way. Alright. Yeah, so we're making a line. LN gives us a 2-point line. Our first point is going to be the evaluate surface point. And our second point is going to be the start point that we created earlier. So the start output of our endpoints goes in there. Let me just double check that I got that right. Nope. Okay. Other way around. So that goes into the B, and this one goes into the A. And we're going to do another one where the end goes into the A this time. So the S goes into the first one, and the E goes into the second one. So has everyone got that? Great. Okay. We're just going to grab the length of those. So this is just a component that measures the length of each of these lines. And we want to flatten this length because at the moment, each of these lengths is in, I think, a separate tree. Yeah, so there's 3 of them in each branch. So we want to flatten it so that we just have one straight list. Just like that. So we need to remap these numbers and create what's called a domain. So essentially what this does is we create a maximum length. So basically the distances are going to be remapped from 0 to 1, right? So the maximum distance of one of those lines that's connected from the sphere to our junctions is going to be redefined. Instead of like the actual length that it is, it's going to be redefined as 1, and the shortest length is going to be redefined as 0. Yeah? And that'll just help us to gauge how far we need to actually make our spikes. Because we need to multiply their length later by a number, and if we multiply them by the actual length, they'll be like astronomically long. If we multiply them from something between 0 and 1, they'll scale correctly. All right, so we need to remap these numbers. So we'll pop that in there. We need 2 of them. We need to create bounds as well. And this is just going to set the minimum and the maximum number. So just set these up here. Remap, remap, bounds, bounds. While I quickly check what to connect them to. And we are going to construct a domain. Construct domain. So essentially we want this to go from whatever minimum length we want our spikes to be. So we still want there to be spikes, so we don't want it to be 0. Otherwise we're not going to see any spikes at that location. Unless that's what you want, it's fine if that's what you want. But for this one, we're going to make sure that the minimum distance of spikes still makes sure that the spikes are visible. So instead of doing 0, I'm just going to do 0.1. And then like 0.99, right? And let me just see, which order have we got this connected to? Yeah, okay, so the domain end, because it's backwards, it's reversed, it's actually calculating it in a different direction. So we got to split those. So just oh, that's fine, actually. You know what, doesn't matter. Doesn't really matter. As long as the highest value is on top and the lowest value is on the bottom. Make sense? Because we're working backwards from 1. Okay, so our construct domain is going to go into the T of both of these. T is just the target domain. Let me just check if I've got this right. Yeah, okay, that's good. Target domain. S goes into bounds. V goes into L. Okay. So V is the value that we have to remap, and the value that we're remapping is just the length of all of these lines. So that goes in there. And then S is the source domain. So it doesn't really matter what the source domain is. It's just the length. So we're just remapping the shortest and longest of each of these lengths to be equal to 0.99 for the longest and 0.1 for the shortest. Yeah? So that's that. We've created our new domain, which is just sort of like a dimension of numbers from the shortest one to the largest one. All right. Okay, so now we need to partition the list by the list length. So essentially we want to figure out how many of these lines we created. So list length will tell us how many indices there are in the list. So we'll do that for both of these. So we've got 2 list lengths, and we're going to partition the list so that each of these lengths corresponds to like one branch of the tree. So let's partition this by that. So we'll create 2 partitions, that by that. So let's have a look at what the output was before when we remap the numbers. So it's just a bunch of numbers, right? So you can tell that this, whatever index 18 corresponds to, that's the longest line that we've got. And then if I do this, all of these should be in their separate sort of tree. Your partition list is orange. Does it come out of the line or the line length? Yeah, so it should come out of the line. Let me have a look. Oh, you haven't connected your remap numbers to it. Oh.
No.
That's the right. So that's consecutive constructed. All right, so then we're just going to multiply it by the maximum spike distance that we said earlier. So I'm going to go here and type in multiply. We need 2 of these. Let me just double check. Yeah, okay, cool. So this goes into the B of each of these multipliers, and then our maximum spike distance that we set earlier, which, where is it? Hang on a sec. Yep. This was our maximum spike distance, so I'll just rename that. I'm going to pop it up here with all the rest of our parameters. So this, hold shift when you connect it, also goes to the multiplication A input. There. So what essentially we've done there is we've multiplied all of these lengths by the, it's essentially like a scaling factor. So each of those lengths is scaled by a number between 0.1 and 0.99, which is going to inform how big our spikes are, how long our spikes are. The maximum spike distance, which is connected to this, the offset surface, yeah. All right, and then that multiplication, the result is going to go into our amplitudes up here. So I'm going to shift this along. That's going to go into our amplitudes, just like that. So now you can see we've essentially just got our things here. You can see that these ones that are close to the sphere are closer to the surface, whereas these ones that are further from the sphere are further from the surface. Yeah, makes sense? Oh, yeah, yep. Let me just double check that this is right. Right, okay. So, sorry for 1 sec. Just flatten the list length here, and then simplify your partition. Yeah, that's my bad. Yeah, so flatten the list length and simplify the partition. Why is that not working? That's weird. Is that a... If I change this display... Yeah, okay. So just find wherever you put the amplitudes before and then shuffle them along so that they're behind the multiplications. That's okay. We're not gonna... We haven't got up to the spike yet. It's just supposed to look like this with a bunch of curves, points inside the offset. Yeah, sorry. Yeah. Yeah, that's it. Yeah. It's fine. Okay, so see how I've got the ring up? So that's the ring up there. The output goes to the end of yeah, hang on one sec. Yeah, I realize this is probably the most complicated part. Yes. Yeah. All right, has everyone got sort of like a if I turn all this off, essentially what we're looking for is just a series of points. Yeah? And then when we move our MD slider, these points change distance. Yeah? So they go further out the closer they are to the attractor point. So if I turn everything off except for those final moves, then as we move the MD slider, our points change their distance. So if I move my sphere, all the way up to the top here, this will be the longest point and this will be the shortest point. And then if I move the sphere along the surface, basically...
When I turn everything off, it's just dots everywhere. There's no like frame or anything.
Like by everything, I just mean like everything that we just did here. Yeah, if you turn everything off, you're not going to see anything. That's sorry, I should have been more specific.
Has like two XC things. I have like I don't know what. Right. Crosses everywhere.
Just turn off all of that.
Yeah.
Yeah, that's right. Sorry, can I jump in?
I'm going to like everything. Like I'm so bad. Oh really? Oh, I've seen this stuff though. That's so nice. Oh, there's like just $30. I'm just yeah. So I can never actually use like a discount code with the actual discount. Yeah. So I always just buy it. Have you got anything you can try? Anything to say on there? It's like I don't trust them.
I mean, it looks fine, right? There's probably something.
It's why you get the back end. That's why. Do they have a reviews? Because even if mentioned they will say something that's
All right. So also, I noticed you were using Citrix as well. Um, if you're using Citrix, which I think some of you are, you're using Citrix. Um, what you'll have to do when we get to the next point, which is Weaverbird, using that plugin that we installed earlier. If you're using Citrix, just save your script there, install Rhino on your computer. Like, what do you mean?
It doesn't. I can't use Rhino on my computer anymore. It needs a license thingy.
Make a fake account.
It doesn't work. I already tried. I tried 3.
All right, after class I'll try. But basically, you need your own version of Rhino on your computer to install plugins, and this requires a plugin. So if you're using Citrix, just save it after we get to the next point, and then follow along with the tutorial at home to do the Weaverbird stuff. But for all of you who do have Rhino, I'll keep going. All right, so we have our move points. Where are they? They are here. We're going to merge them. So we're going to grab merge.
Which move? After the.
Those two, yeah. So the first one is going to go into D1, and then we're not going to put anything into D2 yet, except for this evaluate curve. So way back here, evaluate curve goes into D2, and then D3 goes into merge.
Is it the one before the axis?
Just the point of the evaluate curve.
Which one goes into the evaluate P?
Yeah.
Goes back. Where the spike is.
So then we want to use a polyline.
Yeah, so behind it.
That doesn't look right. Oh, we have to graft it. That's better. Okay. So, graft D1 and D3. You don't have to graft D2. The evaluate curve that you used earlier.
Yeah, for the spike distance, right?
Yes, for spike distance, yeah.
Oh, this one is.
There you go. So make sure you've grafted whatever you need to graft. Okay. Then we have a couple of excess branches in our tree, so we're just going to trim it. So trim tree. It doesn't do anything visually, but it just cleans up our tree. And then we're going to join curves. And then simplify those joined curves. So just to go back to it, this is what it should look like.
Nothing has changed in the past half an hour. Mine looks the same.
The evaluate curve. So if I trace it back, it's back here. So this is what connects to D2. All right, let's have a look. Have you remember to like turn off the display for stuff that you're not working on, and then turn on the display for stuff that you are working on.
What section is also not like so yeah, yeah.
Okay, I'm gonna zoom in on one of the junctions then. Like on the runner, yeah. Yeah, okay, so that's
Those pressed into
so I think maybe your spike distances. No, there's yeah, hang on one second. So, what might be happening with you guys is your trees are sort of, so your lists are sort of out of whack. So make sure that your evaluate curve here is grafted and reparameterized. This evaluate curve here. So this is what connects to your spike distance and to your D2 of the merge. So make sure it's reparameterized and grafted. Okay. What else? What else do we have? So, yeah, that's good. Your length needs to be flattened, both of them. Your list length needs to be flattened, both of them. Your partition list needs to be simplified. And your merges need to be grafted, just D1 and D3. And then join curve needs to be simplified. Okay. The polyline?
Yeah, mine's orange. Mine does not.
Alright, I'll go back to it later because we're almost at the end. So I just want to power on to the end and then we can troubleshoot at the end.
Yes, I would need to troubleshoot.
Anyone else got any problems? You guys good? So you go east to west. Your polyline.
Oh, that's just the radius. Mine's like for yours. Someone was very like, yeah, I was I'm like, okay.
Yours is good?
Oh,
Yours is
I think it's just rain and stuff.
what about,
In the
okay,
morning,
yep, that's good. So we'll, I think we probably have the same problem. So wait until that. All right. So Yeah, that's all good. So I think a couple of you guys have the same problem, which I haven't figured out yet, but we'll figure it out later together. But for those people who have got it so far, we'll move on. So what we're going to do now is add some like thickness to our spikes. So essentially what we're going to do is create so don't worry about this. This is from the example earlier. So we're just going to essentially create a accompanying list for our spikes of these sort of like edges here so that we can create a boundary for our mesh later. If that doesn't make sense, that's okay. Yes. Okay. Wow, this is a long script. All right. Okay, so from our scale. We're going to create a scale component. The geometry that we're going to scale is our polygon center. Sorry, is our joined curves. That's my bad. So these panel boundaries that we had way up here are going to come down into the geometry of our scale. So that scale that we got, the geometry is our panel boundary. The center of our polygons is the center point for scaling. Okay, I'll go back. All right, sure. So I'll put this up here for now. So our panel boundary is a set of curves, goes into G. Our curve center from polygon center goes into C. And then let me just double check where the F comes from. It comes from, yeah, okay. So we're just going to put another slider in here from 0 to 1. I'm going to call this one spike edge width. This essentially just sets the maximum width for our spike edges. All right, so now that we've got all of that connected, now we can drag it down here and start working on it. All right, so the next part is to explode it, get our endpoints, evaluate the curve. So let's go do that. So let's explode it. We are going to graft it and simplify it, I think. Yeah, graft and simplify. We're going to grab the endpoints of each of these segments. Yeah. We're going to evaluate curve. That goes in there too. And the T for evaluate curve is going to go into our negative expression that we came up with here. Sorry? Yeah. All right.
Wait, where did that come from? Oh, I'm kind of an idiot. You know what's really good for coding?
That's all good.
Why is it orange?
All right, so the okay. Yeah, okay. So this goes to our expression that we came up with here.
Which one is two of them?
They're just the bottom one, x minus 1. Oh, 1 minus x.
X minus it's one minus x.
1 minus x, sorry.
Again, nothing's happening. It's just
All right, I'll come back to yours later because I think a couple of people are having the same problem, but this is just for people who are caught up. We'll keep pushing on. So we're going to merge all of these points together. Same way we did it before. We're basically constructing that pyramid shape. So if I go to merge, same thing we did before. S goes in there, P goes in there, and E goes in there. So we're basically creating a triangle, right? Where the start point is the first point there, the midpoint is our evaluate curve, and the end point is the end point. Yeah? Let me just check if those are grafted. They're not actually, so that's fine. So if I go to create a polyline now, it should give us sort of like a mirror of our, yeah, here we go. So now it should give us our proper edges here, which connects to these. And now when we loft these together, we're going to get our spike geometry.
You merge them. These two. Yeah. So for S and one, P into
And we're just going to trim this tree to be safe and then join. So what we've done there is we've created lists that are in the same sort of structure, one for the spiky bit and one for the boundary that will enclose the spiky bit. Is anyone actually up to this part? Or am I too... Yeah, you're good? Yeah. All right, so if you're up to this point, well done. I know this was sort of one of the most difficult tutorials that we've done so far because it has a lot of tree manipulation and a lot of lists that we haven't really gone into the detail of. But I just wanted to give you sort of like a surface overview of what's going on. All right, so we have our two curves there. So we've got our spiky ones. Yeah. And we've got our boundaries for the spiky ones. Probably best to, yeah. So essentially, our geometry should look something like this.
There's so many X's.
Yeah, okay. That's all good.
The reason why it got so crazy was because of freaking Bruce.
Okay, so just figure out where it should start grafting. So just figure out where it should start turning into dotted lines, and then graft to that point. Yeah, so figure out where it should have started, which is this explode probably. Nothing. Sorry? Yeah. Like that. Yeah, okay. All right. So I kind of want to get through, because I figured like a lot of people are having problems with this, so I want to get through it quickly so that when you're watching it at home, it's not tedious to get through, you know? So, no. So we're just going to merge these now. Are we almost there? Yeah. Are we there yet? So we're going to merge those two joined curves so that they're sort of connected like this. And then we're going to loft them together and create a mesh out of them. So loft. You don't need to make it that detailed. You don't need to do every step. You can simplify it. Okay, so we've lofted it. Now we need to turn it into a mesh just like we did before. So we're going to just go simple mesh. So now when you've meshed it, I would recommend turning off everything else. So we have our mesh. Then we're going to join it after we flatten it, obviously. So flatten it like that, and then mesh join. And so now this should join all of our disparate meshes into one. So we had 40 meshes because we had 40 curves. And now it's into one mesh. So everything seems to be working out.
I think mine is spiky.
Well done.
I don't know what I did, but spiky.
That's, yeah, no, awesome. That's really good. That's really good. All right, so just to recap, just to recap, essentially what we've got here is we've created our surface over here. Let me just turn off the display for all this so we can build it up bit by bit, right? So, just to recap, this probably isn't going to fix your problems, but it could help you understand how the script came together. So, first thing we did, we created our surface and subdivided it like this, yeah? Next thing we did, we created these rigid panels, right? Instead of what we had before. We still have our axis center point, and that can change. Then we made our cells. So we have an external frame, an internal panel border, and an interior frame. That gives it some thickness. Then we merged all of them together, so we came up with this kind of shape. Yeah? That's at the top over there. Now, if we go back to the attractor point stuff, what we did was we created like a point, which is our attractor point. We created a bunch of vectors, defined a bunch of vectors, so that our the maximum distance of our spikes moves in relation to how we move this attractor point, right? So you can see as the points get closer to the sphere, they increase in length. Rather, probably a better way of saying that is as the sphere gets closer to the points, they increase in length. Yeah? Cool. So then, what we just did was we joined all of these curves together, all of the curves that define the spikes. We merged them, and then we created a mesh out of them. Right? So if you're on Citrix, now would be the time where you save, and you're basically done for today. If you manage to get Weaverbird installed properly, I'll go through that now. So Weaverbird is the plugin that we installed earlier today. All right, so I'm just going to use grab like a mesh geometry and move it over here. Would it be more helpful for you guys to split this into 3 parts? So we have like the first part, the attractor point part, and then the weaver point part? Yeah, okay. All right, so I'll stop the recording here, and then when we're yeah, so this has already been like an hour and 20 minutes. So this is why I kind of wanted to keep the recordings short so that you guys don't like have to slog through it at home. So I'll stop recording now.